Let us see why we need a presentation pattern. When we build applications, we want our code to be maintainable, testable, scalable, and well organized. To achieve this, we use presentation patterns, which help us to clearly separate the UI, presentation logic, and business or data logic. Let us discuss about the popular presentation patterns in Android. First, let us discuss about MVC or Model View Controller. In MVC, view is the XML and the controller is the activity which controls the view. Now let us see how MVC works. Model layer provides the data from database or from the network. We normally use a room database or retrofit library for network calls. So controller will get data from the model layer and it will display the data in the view. This is the overall working of MVC. Now let us see the advantage of this pattern. The disadvantage of this pattern. Controller becomes too heavy. Since activity has all the code to handle the business logic and presentation logic, controller will be much heavier. Also, the activity will be responsible to display data inside the XML. So there is a tight coupling between the view and the controller. So obviously poor separation of concerns. Since the activity has major portion of the code code will be difficult to maintain, test, and also it is less scalable. Now let us discuss about the next popular pattern, that is MVP or Model View Presenter. In MVP, the controller is replaced with the presenter. Also, activity of fragment and XML is part of the view layer. And we have a separate class for the presenter. MVP also works in a similar way like MVC. Presenter gets data from the model layer and send it to the view layer to display the data. Here the main purpose of activity or fragment is to display the data from the presenter or request data from the presenter on user events such as button clicks. The role of the presenter is to convert the data to a presentable format. For example, sort the data or filter out unwanted data. That is why it is called a presenter. Also, each view has a dedicated presenter. Now let us see how view and presenter communicates with each other. View holds a reference of the presenter and presenter holds a reference of the view. In other words, both of them knows about each other. View and the presenter communicates with each other via interfaces. Now let us see the advantage of this MVP pattern. Separation of concerns. Now the purpose of the activity of fragment is to just display the data from the presenter or forward button clicks or inputs to the presenter. So presenter is going to handle all the presentation logic. So better separation of concerns. Easy to test. MVP is easy to test because view and presenter communicates via interfaces, which means they are loosely coupled. This allows us to easily mock the view or the model while testing the presenter's logic. So all these points make this pattern easy to maintain and scalable as well. Now let us discuss about another popular pattern, that is MVVM or Model View ViewModel. In MVVM, presenter is replaced with the ViewModel. But what makes the ViewModel different from a presenter? In MVP, view and presenter knows about each other. But in MVVM, view holds a reference of the ViewModel and ViewModel does not hold the reference of the view. In other words, view knows the ViewModel, but the ViewModel does not knows the view. So we can have multiple views bound to the same ViewModel. For example, say we have an activity and multiple fragments or composables. We can use a shared view model which can be used to share data between fragments and activity and composables. Now let us see how MVVM works. View model exposes a state. Since view is aware of the view model, it will observe the state and renders the UI. Remember, in the case of MVP, presenter need to send data to the view, but in the case of MVVM, UI update happen automatically due to the observer pattern. Assume that I have to get a list of data from the server or database on click of a button. So button is part of view layer. When user clicks on a button, view send events to the view model and view model gets data from the model. View model update the state and the data will be automatically updated in the UI since the state is observed in the view. So this makes the UI reactive. We have an existing class for ViewModel in Android library. Since ViewModel is a subclass of the Android ViewModel, ViewModel is lifecycle aware. That means ViewModel will get destroyed only if all the views bound to that ViewModel are removed from the screen. For example, assume that an activity and two fragments using a shared ViewModel. This shared ViewModel will get automatically destroyed when activity and both fragments get destroyed. Now let us see the advantage of MVVM pattern. So MVVM has all the advantages of MVP like scalable, testable and maintainable, but it has some extra advantages. ViewModel, as we discussed, is lifecycle aware. So ViewModel automatically clears resource when the view is destroyed. Less chance for memory leak. Also, ViewModel survives configuration changes, so the state values will be preserved. And we can use a shared ViewModel to share data across activities or fragments. And UI is more reactive to data changes. So in summary, MVVM makes Android application cleaner, more maintainable and easier to scale by enforcing a clear separation of concerns and enabling a reactive lifecycle aware UI. Thank you for watching.